Hi everyone, this video is on exercise 9I question 5 of Pure 2. So we have the curve with the equation e to the x times x squared minus 2x plus 2 is equal to y. And for part A, we want to find the exact coordinates of the stationary point, which is something that you should be familiar if you're in this section. And also, we need to determine its nature. Okay, so normally when you're asked about determining the nature of a point, a stationary point specifically, that's about its second derivative. Right, so as usual, we are going to differentiate this function. Dy dx is equal to, so this is the product rule. So the first function is e to the x times the derivative of the second function, which is 2x minus 2, then plus the derivative of the first function, which is e to the x times the second function, x squared minus 2x plus 2. But remember that we want to solve the equation dy dx is equal to 0 because we want to find a stationary point. But before that, we can factorize to just have a nicer form. So we can take a factor of e to the x so that we are going to have 2x minus 2 plus x squared minus 2x plus 2. And there are some cancellations here because we have 2x and minus 2x, also plus 2 and minus 2, which makes this very nice, and we are only going to be left with x squared. So x e to the x times x squared. This is the first derivative, and in order to find the stationary point, we solve the equation dy dx is equal to 0, which means e to the x squared is equal to 0. And remember that the only possible solution here for this equation is just when the value of x is equal to 0, because 0 times e to the x, obviously e to the 0 is 1, 1 times 0 is 0. So that's the only possible value for this equation, that x is 0. That's the only solution. And we need to find the y-coordinate of the stationary point as well. So we are going to substitute 0 into the function of y. So when x is equal to 0, then y is equal to e to the 0 times 0 minus 0 plus 2, which simply is equal to 2. So that means the stationary point has coordinates 0, 2. So this is the coordinates of the stationary point that we found. But we are not done yet because with part A, because we need to determine its nature. So that means first, when you want to determine the nature of a stationary point, first find a second derivative. That's the first step. So d2y dx squared is equal to dy dx is e to the x times x squared. So we use the product rule again. E to the x times 2x plus e to the x times x squared, because the derivative of e to the x is just e to the x, so that times x squared. And again, we can take a factor of e to the x. We'll have 2x plus x squared. Then now we are at a position to determine the nature of the second derivative. Okay, in order to determine the nature of x, or the stationary point, which was, remember that x is 0, so to highlight that, in the stationary point x has a coordinate 0. What we do, we substitute that value that we found from the first derivative equal to 0 and substitute that into the second derivative, and then based on the value that we get as a result of that, we can determine the nature. For example, if the value is positive, then the function has a minimum. If it's negative, it has a maximum. And if it's 0, it's interesting. And in A level, we consider that as neither maximum nor minimum. So now in this case, we use the value that we found by setting the first derivative 0. So when x is equal to 0, then the second derivative is equal to e to the 0 times 0 plus 0. So that's interesting. We got 0. So we didn't get a positive or a negative value. We just got 0. So in this case, we can conclude that, as you know, in terms of the nature of the point of the stationary point, that's neither a minimum nor a maximum, and it's just a stationary point of inflection. So it's yeah, just to write that here. So it's a stationary point of inflection. Okay, and when I solve part B, this might even make more sense, because part B is about finding the points of inflection. So part B, we need to find the coordinates of any non-stationary points of inflection on C. So in order to find the points of inflection, obviously we solve the d squared y over the by dx squared to 0. So we solve this, and for the value of second derivative, the equation of second derivative, we got e to the x times 2x plus x squared, and we want to solve this equation. So again, e to the x, either e to the x must be 0 or 2x plus x squared is 0 in order for this equation to hold. But we know that e to the x can't be 0. So that doesn't have any solutions. But what is going to have solutions is the second one, which is, so e to the x can't be equal to 0. But what we have instead is that 2x plus x squared can be equal to 0. So we can take a factor of x to have x plus 2 is equal to 0. So either x is equal to 0 or x is equal to minus 2. So we have already, talked about this. Remember, these are the points of inflection. So we have already talked about the point of inflection, that this was also the stationary point. So this turned out to be the stationary point and also a point of inflection at the same time. But we haven't talked about this yet. And the question is exactly about any non-stationary points of inflection on C, which is when it's minus 2. So we only need to, if you remember from the previous video, just basically analyze the behavior of the function when x is minus 2, just before and after minus 2. So what we do, because we want to show that, that's the point of inflection. So in those cases, if you remember, we found f double dash x at minus 2 plus 0.1 and also take away 0.1, because that gives us the behavior just before and after that point of inflection. And if we get two values with opposite signs, then that means that's the point of inflection. Otherwise, if we get two same signs, then that means that's not a point of inflection. So now we first write down when we have minus 2 plus 0.1, then the 2y dx squared is going to be, so now it's all about substituting this into calculator. And also the second test is when we do when minus 2 minus 0.1, then d squared y by dx squared is equal to something. Yeah, now we just substitute this into the value of dy squared by dx squared. So for this one, we get minus 0.0 to a to 3 decimal places, which is a negative value. And if we get a positive value for the next one, then that means this is the point of inflection. And for the second one, we get 0.026 to 3 decimal places, and that's a positive value. So since we got two values with opposite signs, we can conclude that when x is equal to minus 2, then this is a point of inflection. Actually, we need to find the y coordinate, but this is the x coordinate of a point of inflection. So when we substitute this into this equation of d squared y dx, so the y coordinate is equal to 10e to the power minus 2. So basically, this point of inflection has coordinates minus to 10e to the power of minus 2, which was what the question was asking, to find the coordinates of any non-stationary points of inflection. All right, thank you for watching.